Hello.
Buenos días, mister.
Morning, morning.
How are you?
Fine, thank you. And you? What about you?
Nothing new.
Okay. So I'm looking Luis Manuel, Wilmer, who else?
Just us.
Okay. If you have
Uh,
if you are in the WhatsApp group with your classmates, you can tell them that
yes, I'm gonna.
can you send the invitations to Vicky?
Yes,
Vicky,
yes.
okay? For Vicky's phone number.
Okay.
Okay, I'm looking some more students. Maria Hernandez.
Okay. Victoria says she's up to enter, mister.
Okay.
¿A dónde está el cargador de la laptop pequeña?
Yes, here is Maria, here is Daniel. Can you see the screen? Can you see the screen?
Okay. Okay.
Can you see the presentation, the PowerPoint presentation?
Yes.
Good morning, everybody. In 1 minute, we're gonna start the class. If you can send the invitation to your classmates, please, because
Yes.
I'm just looking like 7 students right now.
Okay.
Yes, I think that Vicky already received the invitation I sent. Okay,
Yes.
it's okay. Scarlett. Okay, it's 9 o'clock. We're gonna start the class right now.
Yes.
The idea of have this meeting by this way is conclude the work we couldn't conclude the week of class we had, and practically is about this, the unit circle.
Okay.
So last time we were talking about the unit circle, just finishing or using some tools in order to construct the
Mhm.
or build the whole circle. I think we use the protractor, we use the ruler, we use
Yes.
compass, we use all
Mhm.
those tools in order to um, make that shape. But we just finished the first part of the unit circle. Practically, we finished the inside part. If you remember, we had the degrees and the radians inside. All that division we did is useful in order to understand better this unit circle. So practically, this is what I want to tell you first, the description that the interior part of the circle, it's done. We make the division in degrees, and at the same time, excuse me. Buenos días. Good morning. Morning. Yeah. Vengo de parte de doña Sae
The railway reports a big disappointment.
Correcto. Ahorita. Cuando un día se cliente me dice para dar después.
No,
No.
no.
He died.
Pero me ubiqué porque dije yo, de palo de almendra, dije yo he visto una repostería para el lado de abajo. Tiene que ser, y yo venía el doctor y me dijo, mire, ese hermano, bueno, vamos a ver con esta liquidación que hemos estado que realizar. Bueno, estamos así, mire cómo estamos, así de cerrado. La gente que no los bancos aprovechen a venderle a dejar su dinero. Porque yo no me quiero enojar. Un día hay que aprovecharlo, porque mañana y a saber hasta cuándo. Así es. Excuse me, guys. Just
Yeah, mister.
it's just that I'm not in my house right now. I'm in I'm in another place right now. Okay, because I don't have internet in my house, so I have to come in here. But still being 9:05. So I was saying that the interior part of the unitary circle is done, but we're gonna concentrating with this presentation in the exterior part. So if you have a question, you can speak in any moment. Okay, it's not an interruption. It's just your participation, so you can speak in any moment if you're not clear. Probably I will not be answering by the chat. Okay. So I will answer better if you just speak, just say something. Okay, no problem. Because been looking here, the chat is like um, breaking apart the idea. I mean, it's like a little distraction. So please, if you want to say something, say it. No problem. If you have a question, say it. Okay. Talking about the description, I already explained you the interior part. We already did it. Then you're gonna do this job later, right? We can um, use the YouTube presentation I'm gonna make, the YouTube video with this presentation we have right now. Okay, talking about today thing is the exterior part. And what do we have in the exterior part? In the exterior part, we're gonna have many coordinates around that unit circle. We're gonna have x comma y points. Remember that we made this in a coordinate plane. So this coordinate plane has coordinates. So how's gonna be the unit circle we want? It's gonna be like that. Of course, that one looks ugly and yours is gonna be better. What I wanna say is
He
that we
thinks
have the interior part done. All these angles, the 0, 30, 45, 60, all those degrees and those radians at the same time. Yeah, I know that we made like divisions like this one. We made the lines right here. In this one, you don't have, or you can see the line. They are not in here. But something interesting about this unit circle is the name. First, why it's called unit circle? Do you know why it's called a unit circle?
no.
Someone else? You can participate. Question is, if you know why it's called unit circle. Nobody?
I don't know.
Okay,
A
it's called,
lot of coordinates.
reason is because of the radius. The radius of the unit circle is 1. That's why this point in here is 1, 0. 1 in the x, 0 in the y. And if you see, there are some similar point like this one. Is this one, this other one, this one, and this one. Practically, those are intercepts, and where the unitary circle intercept with the Cartesian plane, if you see, there are some points, and all of them behaves the same. Just that the point, the 1 maybe and the 0 are in different position, of course, because remember the points are x comma y, so x first, then the y. This is very interesting. For me, it could be easy. Just ask you to print this unitary circle and you're done with this. But I don't want that. I want you to understand why those values goes or behaves like that. And we're gonna discover why these values goes in here. So first, we have to be clear that the radius of the circle, I mean, every segment that you make from the center to the circumference will measure 1, okay? Of course, here, from the center to the circumference, it measures 1, just that because you're in the left side of the x coordinate, you go with a negative value. If you go down, what happened? You go with a negative value in the y. So those are things you already know. And let's see how these things can be useful right now in order to conclude why those values we have in here are there. Okay, so this is what we're gonna do, and we're gonna make some analysis. I hope you saw the YouTube videos, because those will help us specifically, because we're gonna use some unit, some spatial right triangles that are useful in order to find those values. So look, now this one looks better, but yours gonna look much better. And this is what we're gonna do. We're gonna find those missing values in here. Practically, I do this because I want to show you that. Finding this value, for example, then you can find this one, and this other one. Okay. So how can we find this value? Very easy. We're gonna use a trick, and the trick is use this spatial right triangle. You will see it like right now. It's an interesting right triangle. There he is. And this right triangle have some characteristic. Okay, just gonna explain you something. The length of that side, okay, which is like the bottom one, will be your x coordinate. Suppose that until here you have like 0.80. So x coordinate here is 0.80. So this one, the one I'm showing you right now, this other side, will be your y coordinate, okay? Suppose that is like 0.40. So if this is 0.80 and this is 0.40 in the y, the point here is supposed to be 0.40 comma, sorry, 0.80 comma 0.40, okay? First the x and then the y. So this is what we're gonna do essentially. We know something about this triangle. We know two things. First, look this. Look the opening. Look the opening. The opening here measures
30 degrees.
30 degrees. So if this measures 30 degrees, means that this angle in this triangle measures 30 degrees. Do we know something else in this right triangle? Yeah, you're gonna tell me this is 90 degrees. I'm totally agree. And you can conclude the measurement of that angle too, but about the sides, do you know one of the sides or not? What do you think?
Yes.
Which one?
The hypotenuse
Hypotenuse must be?
1,
Why?
because every point from the center point, the 0, until the one of the sides is gonna be 1.
Okay, every point from the center to the circumference is a radius. And because that's a unit circle, the measure of this one must be 1. Okay?
Yeah.
So we're gonna work just with this and find those sides in order to conclude what are the x and the y coordinates. So I'm gonna use this right triangle. It's called spatial right triangle. The name of this one is 30, 60, 90 degrees. What a name, right? It's because I have 30, 60, and 90 degrees. So that's the name. And if you see, it shares a lot of characteristics with our one. They are very similar. If you see this angle is 30, this angle is 32, the 30, I mean. So we can conclude the measurement of this one because we already know that one. I'm sure this one is 60 because that one is 90. It's a right triangle, so practically they are the same. Just a little explanation about this one. This works like a formula, and what you need essentially is know the value of x. If you know the value of x, then you know the length of the other 3 sides. It's always like that. This is what we're gonna do in here, but in here we don't know that side, which is the value of x, right? We know that one. So we can create an equation using this one and this one. Why those? Because those are the hypotenuse in each triangle. So how this is gonna be, practically I'm gonna make an equation, and this equation is like the secret of how to get the value of x in this right triangle. Remember, we need the value of x to get the missing side. So how can you get it? Easy. Making the simple equation, saying that 2x is equal 1. And it's true because both are hypotenuse, okay? Both are hypotenuse right now, and in order to get this, we solve that simple equation, solve it for x, that 2 is multiplying positive divide, so x is equal 1/2. What does it mean? This side will be 1/2, you will see in a few minutes. And we can conclude something else. I mean, if we know x, then we know the rest of the sides. Of course, 2 times 1/2 is gonna be 1, and we already know that information. But here, what about that one? To get that one, you know that x is equal to 1/2. Then you can conclude that this side is gonna be 1/2 square root of 3, or simplifying is gonna be a square root of 3 over 2. So that information is very important because with this information, we will find those sides. So here is 1/2, and here is the square root of 3 over 2. At the beginning, I explained you that we need those sides because we want to see them, and we want to see what coordinates they make. If you remember, this bottom side is related with the x coordinate, and that one is related with the y. I'm going to show you this right now. Of course, we need to be clear that this is going to be on the coordinate plane. And once you have these, all you need to do is like plot the points. So just to have it more clear, I'm gonna move the numbers and you will see which coordinates they make. So practically the length of that side is exactly square root of 3 over 2, means that the point, the x coordinate that goes in here is square root of 3 over 2. And the same is gonna happen with the y one, okay? So the length from here to here is exactly 1/2. That's why the coordinates we have in this point are a square root of 3 over 2. And yeah, that's the information that we have in here. So look, this is what we have. The triangle, which has 30 degrees, hypotenuse 1, that side is gonna be square root of 3 over 2, and that side is 1/2. So what are your coordinates? I told you, those are square root of 3 over 2, comma, 1/2. I think now you're clear. If you're not clear, you can make your question right now. Are you clear with this? Or any question? Any question?
Can you explain it again?
Excuse me?
Can you explain it again?
What part?
I entered late, so I don't understand.
You will see something, I mean, you can see the video. Can't explain this again because we have just like 30 minutes to finish. A question? I'm gonna explain something very related with this, but then you can see a video on YouTube. Someone else. Something that wasn't clear. Be specific, please. So if you're clear why that happened, now you're gonna be clear what happened with this value, and this other one, because practically, if you see, this triangle fit exactly in this one, in here, and in here. So same situation is gonna happen, just that I'm sure that you're totally clear that here are not 30 degrees, are 150, but in this space, this triangle fit. The same in here. Here you have 210. So in this space, this triangle fit. And in this one too. So practically, these coordinates, square root of 3 over 2, comma, 1/2, will be here, here, and in here, just that change the sign. Because remember, the x to the left is negative. And the y moving up is positive. What do you think in here? How's gonna be the coordinate in here? How do you think will be the coordinate here? Or what's the coordinate in here? It's gonna be the same
The two of them
values.
negative.
Both of them negatives. I'm totally agree. Yes, it's like that. Both of them are negatives, if you see. Okay? So
Yes.
practically, this answer will repeat in here. Just be careful, because you're moving in the right side of the x, so the x is positive, but you're moving down. I mean, this point is down. Hey, do you remember to think of the quadrants in the coordinate plane? In first quadrant, both coordinates are positive. In second quadrant, the x coordinate is negative. In the third quadrant, both coordinates are negatives. And in the fourth quadrant, the x coordinate is positive, the y coordinate is negative. So practically it's the same in all of them, just that the sign have to change, of course. So do you have any question about this?
No.
Any question? I can't explain all again, because then we will not have time to finish. Then you can see the video, the YouTube video. I'm gonna upload like at 1 or at 12, and it's gonna be on the platform. I can share this link, this YouTube link too, with your president, no problem. So if there's no any question, let me tell you that we're gonna do something a lot similar with those points, these ones, okay? So I'm gonna jump this one right now because that one is 45 and it requires another spatial right triangle. But that one, which is 60, it's a lot related with the procedure we did right now. So practically those answers will be here again, but not in that order. I think we'll change, something will change. But look, here we have another triangle, and it's another spatial right triangle. Of course, is that right triangle of 60, 30, and 90 degrees is practically the same with the other one we already did. So this hypotenuse still being 1, and let's make the same analysis we did with the other one. Any question right now? Why is 60 degrees? Maybe is your question. Okay, because the opening we have in here is 60 degrees. Okay, so let's make the analysis. Remember that you can make your question in any moment, no problem. Okay, I'm here for your questions. And I was expecting that you saw the YouTube videos I sent to the platform, but I think just like no, not a lot of students. Or you don't have questions because you're totally clear. So going on. Here you have, here we have the spatial right triangle. If you see, it's exactly the same as the other one because the other one have 30, 60, and 90 degrees. Yeah, the big difference is that now we're gonna work with the 60 degrees, but essentially they're the same. So here, measurement in this triangle we have, it's gonna be 30 because this one is 90. So this is the spatial right triangle, 60, 30, and 90 degrees, same as the other one, just that I changed the position of the angle. Big difference, right? Same thing. So let's get the value of x, because this is what we need in order to get the other two missing sides, using this yeah, if you're not gonna speak things related with math, don't do it, please, because right now this is a serious moment and we need to use the time for what we need. Okay, so here we go. Let's make we are in class, right? So please use the chat for the class. Or better, don't use the chat. Please. For that, you have WhatsApp and other applications to use it. So here we go. Same idea as the other one. We're gonna concentrate in those values, the hypotenuse and the hypotenuse of the 60, 30, 90 degrees spatial right triangle. And we know that the 2x is equal 1 because those are hypotenuse in order to get the value of x, which is gonna be 1/2. Okay? So knowing that x is 1/2, then you can find the other side. In this case, is square root of 3 times 1/2, which is the same procedure we already did. So we can conclude right now the measurement of those sides. This side's gonna be 1/2, and this other one's gonna be square root of 3 over 2. So this is what we have. And again, we wanna know what coordinates it makes. I'm thinking that you're totally clear what's gonna happen in here because it's too similar as the procedure we did in the other one. Here you have your x coordinate, which is related with that bottom value because it's the horizontal one, and that y coordinate will be related with this because it's the vertical one. If you cannot see it better in the coordinate plane, and we're gonna plot that point. So the x coordinate, the y coordinate, the x coordinate is 1/2. The y coordinate is square root of 3 over 2. And by that way, we can conclude now the coordinates that are hidden in here. So what coordinates, or what do you think is the coordinate in here? Someone please tell me what's the coordinate in here? Or what do you think is gonna be the coordinate in here? Say it.
One over 2.
Excuse me?
60.
Yeah, 60 degrees, but the coordinate here, coordinate will be similar to that one. What numbers will be here? That's my question.
1 over 2, and the next one is gonna be square root of 3 over 2.
You're totally right, sir. It's like that. And it is because this one, again, represents your x coordinate, this one, your y coordinate. So this is what you have in here. And essentially, the same situation that happens in here will happen in the whole circle. If you see this one, which other? This one and this one shares the same, or this triangle fit in these same 3 locations in these ones I show you right now. So here is one of the triangles. Here is the value. If you see, almost the same point, just that a little difference with the sign. Yes, because to the left, the x coordinates are negatives, okay? What do you think is gonna happen here? Who can tell me what's gonna be the coordinate in here? That can be done with this other spatial right triangle. At the same time, it's the same one. So here you're gonna have the 2 coordinates negative, like we did it in the other one. So the coordinates here will be negative 1/2, comma, negative square root of 3 over 2. You see? Last one. Same idea,
See.
just that the x coordinate is positive and the y coordinate is negative because you go down. Okay, the the time is running. They are missing just 10 minutes to finish this meeting. So I'm gonna move a little bit quickly because practically here, same procedure is the same. Same procedure is the same, just that it requires another spatial right triangle. In this case, we're gonna talk about the spatial right triangle of 45 degrees to get these last four values and conclude this presentation. So how it's gonna be? Same idea. This spatial right triangle is called a 45, 45, 90. This 40, 40, 45, 45, 90 makes an isosceles right triangle. So this is what we have, 45, 45, 90 degrees, and we're gonna do the same as we did in the other procedure. So square root of 2x equals 1, solving for x, you have 1 over square root of 2. Here is our little problem. You're not allowed to have square roots on the denominator, so that's why we need to apply this procedure, which is called rationalization, in order just to like pass the square root operator. And here we have that square root of 2 below. The rationalization process is something easy. It's just multiply by 1 essentially, because square root of 2 divided by square root of 2 is exactly 1. So all that I did in here is multiply this and multiply those. And if you multiply square root of 2 by square root of 2 is square root of 4, which is exactly 2. This is the rationalization process, and practically we know the value of x. Value of x is interesting. Value of x repeats in here. Means that the two coordinates are the same. If you want to see this in the coordinate plane, as we have been doing it, concentrating here in that point, we have the x and y coordinate, of course, x, y, plotting these points. Here you have your x coordinate, plotting the other point. There you have your y coordinate. So y coordinate here, y and x practically are the same, right? So the point in here is a square root of 2 over 2, comma, a square root of 2 over 2. Same coordinate. Moving on, we have the same situation in the other three missing values, and if you see, they are practically the same, just that the sign changed many times. So this is the unitary circle, and that's what I need. There's a homework. You have to send me a picture with this, and we need to conclude this work. So the unit circle is useful to get some trigonometric values. We have to use the angles as reference in order to get the requested trigonometric value. So each coordinate have a meaning. This is something interesting, and we need to be careful with this, okay? Something we need to do is be aware with the angle you're using. Sometimes the trigonometric value is requested in radians, or sometimes it's requested in degrees. So how to use the unit circle is something simple. Each trigonometric value is related with one x and one y coordinate. So each coordinate represents one of these values. To find tangent value, you need to mix both coordinates. So here are like the rules we need to use in order to find cosine, sine, tangent, all these values. So here are three examples. One of cosine of 135 degrees, sine of 11 pi 6, and tangent of pi 6. So here you have these three examples. Check it out. It's very easy, the use of the unitary circle. So first, you have to locate the angle of reference. In this case, is 135. Every time you're requesting for a trigonometric value, you need an angle of reference. Of course, cosine work with the x-coordinate. So the cosine of 135 is exactly negative square root of 2 over 2. Something like that will happen with sine of 11 pi 6. Sine of 11 pi 6 is in here. If you remember, sine works with the y-coordinate according with the rules. So sine of 11 pi 6 is the same as negative 1/2. Tangent. Tangent require you do a little bit of more procedure. So what do we need to do? In this case, we need to mix the two coordinates in order to have the missing value. Of course, here you have by 6, and the two coordinates are 1/2, and the x coordinates square root of 3/2. Simplifying this expression, you're gonna have again square root in the denominator, something that is impossible, and this is what you have at the end, applying the rationalization process. So rationalization process is useful when you have square root in the denominators, okay? So final answer, tangent is gonna be square root of 3/3. So sine, cosine values just require that you pick the x or the y coordinate of the point you have. Tangent require a little bit of procedure, something that you call ER operation, but the mathematical name is simplification of complex fraction. And trigonometric values represents a value, and just that the value will change. For example, if I ask you for the cosine of 60 degrees, that is 1/2. But what about the cosine of 150 degrees? Sorry, what about the cosine of 120? It's gonna be 1/2 but negative. So that's what I'm saying in here, that the answers just change a little bit. So I'm missing 3 minutes. I'm gonna move quickly, and I would maybe in the last minute I will hear your questions. So here you have first 5 values of tangent, starting from 0 degrees, pi 6, pi 4, pi thirds, and pi half. There you have tangent of 0 degrees is relate those coordinates. Tangent of pi 6 is relate those coordinates. I think we already, no, we didn't make it, we make another one. Tangent of pi 4 is practically relate those coordinates, is square root of 2/2 divided by square root of 2/2, which is 1. The other one is tangent of pi thirds, and this one makes something similar with the tangent of pi 6, but the answer is the square root of 3 here. Be careful with this, and look this one. Careful with next. Tangent of pi 1/2 relates the value of y over the value of x, and if you remember, division by 0, it's undefined in math, okay? So what about tangent of pi thirds, which is square root of 3, and next one, tangent of 2 pi thirds. 2 pi thirds is in here, if you see, right? If you analyze those values, are almost the same as this one, just that this one is negative. So that's why the answer is negative. Same is gonna happen with sine and cosine. The answers will be the same, just that the sign will change. And if you see tangent of 5 pi thirds, which is in here, 5 pi thirds, relate those coordinates, and those coordinates again will make another answer. So this is very interesting. I think I make a mistake in that one, but don't worry, you can repair this one. I think this one must be positive, and it will give you a negative value, like that one. My point is that they are very similar. All they are very similar, okay? The answers will be the same, just that sometimes it's positive, sometimes it's negative. Okay, it's missing 1 minute. Please, do you have any question? Any question? No questions?
No.
No.
Okay, if I was clear with this, I need you make your unit dot circle, finish it, and a homework. The homework is related with get some trigonometric values, okay? Oh,
Mister, pero usted nos daría los puntos.
it was all, and no, you will get all of them. You will see how is the homework. In the homework, there's one example. So it is all, please. You see the YouTube video to review again, and bye-bye, because are missing 5 seconds. Bye-bye, guys. Thank you.
Bye.
Thank you to share this time with me.
Ciao.
Bye-bye. Take care.
Bye.
Love you guys.
Oh.
Oh.
Menos puntos.